Welcome to our lesson today, and today we are looking at balancing simple chemical equations in chemistry. So before we start, if you need any material to help you pass your Jamb UTME, you need the file containing the list of the most repeated questions by Jamb, or you need just a plan that will work for you because of last-minute preparation. All you have to do is just send me a DM. Here is my WhatsApp number. Connect with me, or you want me to coach you for the exam, send me a DM and let's talk. All right. So the question we have here, Jamb must repeat question 1. The question reads, balance the following chemical equation. These are the options provided. All right. So balancing the chemical equation, what do we do is very easy. All right. They gave us Fe. They put dash here. So now we go indicate what is supposed to be here. Plus, they put another dash HCl. Then it can give us waiting. Dash again Fe, chloride, 3 chloride, plus dash again H2. All right. They said we should balance the equation. All right. The rule of balancing chemical equation or any equation is the left and the right side, the number of moles on the left side and the number of moles on the right side should be in harmony. So if we have 5 on the what? On the left hand side, we should also have 5 too. On the right hand side. So if we have 5 on the left hand side, we should also have 5 on the right hand side too. Okay, 5 moles. All right. So when you look at the left hand side of this equation, we have 1 mole of iron, we have 1 mole of HCl. Okay, 1 mole now we get. But for this side, you see, say we get 3 molecules of chlorine. Here we get 2 molecules of hydrogen. You see? So what do we have to do? When you see 3 below, all these molecules, subscript molecules, it means say you go times and by what you get for here. You go use and take times anything we did here. Anything we did before, the mole, you use this one times and. All right? It's very easy. All right? So what are we going to do now? What are we going to do right now? If we put 2 here, it's not going to be 2 iron. If you look at the right side of the reaction, okay, here, it's not going to be, since we have 2 iron here, we are supposed to have 2 iron here still. Okay? So if we put 2 here also, we are not going to have 2 times iron. It's not going to be how many iron? It's not going to be 2 iron, because this one is 1. 2 times 1, that's still 2. So if we put 2 here and put 2 here, that means we have balanced the iron. Okay, so let's do it. 2. That means the iron is balanced. All right, see, 2 here, 2. 2 times 1, the same 2. 2 here, 2 times 1, the same 2. All right, so what next? Let's see if we can balance any other thing. If we put, okay, since we have 3 chlorine here, 3 molecules of chlorine here, and you know that anything we put here is times this 3. It will not be times this 3. Anything here applies to everything you have here. So this one times 1, that's 2. That's 2 iron. 2 times 3 chlorine, 3 molecules of chlorine. Will not be how many? It will not be 6 molecules of chlorine. So here now we have 6 moles of chlorine because it's 2 times 3, 6. So since it's 6 molecules of chlorine we have here, let's put 6 here. Okay, it will not be 6 times 1. That's 6. That's we also have 6 molecules of chlorine here. Now, here now we can't get, because any mole apply to everything with the compound, all the elements. Okay. So now here we can't have, it applies to hydrogen. That's we have 6 hydrogen. Since we have 6 hydrogen, what are we going to put here to balance this hydrogen to complete it? 6 moles of hydrogen. Okay. Remember, it's 6 that we are looking for. So we have to look for what we are going to use to times these 2 that will give us 6, which is what? 3. Easy as ABCD. Chicken. So here in the equation, on the left side of the equation, we have 2 moles of iron. Okay. On the right side of the equation, we also have the same 2 moles of iron. Okay. On the left side of the equation, we have what? 6 moles of hydrogen, 6 moles of chlorine. On the right side of the equation, we have 6 moles of chlorine. 2 times 3, now 6. We also have what? 6 moles of what? Hydrogen. So among the options, pick the correct options. Let's write out the ratio. 2, the missing number. 6, 2, 3. Among the options, pick the correct option and drop it in the comment section. So let's balance a nuclear equation. Okay, I've taught this before, but since we are treating balancing chemical equation, let me just treat it. It's easy. Okay, it's easy, very, very easy. Remember the law. What you have on the right hand side should be the same, equal to what you have on the left hand side, okay, of the equation. Okay, it should be equal. The mole, the number of moles, or here that we have a nuclear equation, we have mass number and atomic number. Mass number and Z, atomic number. Okay, so balancing this equation is easy. Ensure that the mass number on the left side of the equation balances with the mass number on the right side of the equation. Also ensure that the atomic number on the left side of the equation balances with the atomic number on the right side of the equation. As easy as that, chicken. So here, on the left side of the equation, we have 14 as mass number. If you have more than one compound or element there, you add everything to get the same mass number. So you also have 6 as atomic number. Okay, so we should have this same thing on the right side of the equation. Okay, how is it balanced? On the right side of the equation, we have nitrogen and it has 14. Okay, 14 balanced. Mass number is balanced. Okay, and we have 7. 7 atomic number. Is it balanced? It doesn't commensurate with 6. It's not equal. So what do? We are now going to rewrite the equation. 14, 6, which is carbon, gives you what? 14 7. Okay, we will now use the particle to balance it. This particle, which is electron, showing us that it's a beta decay. Okay, so electron. Since we want to balance this, here we have 6 and here we now have 7. Mass number balanced already. We want to balance atomic number. What we are going to do is -1 electron. Then up here, for this electron, we'll now put 0. Since up is balanced, we'll now put 0. So this space, what is supposed to be here is 0, and down here is supposed to be what? -1. Okay? Balanced. The equation is balanced. So this mass number, -1, which will give us what? 6. Okay? If, let's say, for example, you now have helium, for example, then I'll give you, let's say, example 6. Okay? Then you now have something like this. You now have 14. Mass number balance. Atomic number, you now have 5, for example. What are you going to do? You balance it. Easy. This up here, since up is balanced, you just put 0 there. Then down here, you have 5 here, and you want it to complete 6 to balance. You put what? You put 1 or +1 or 1. The same thing. So 5 + 1 equal to 6. The same thing, balance. Let's move over to the next topic. Welcome to lesson today, and today we are looking at mole concept. Okay, mole concept, very common in Jamb UTME 2026. Jamb, they always repeat questions from here. Okay, if you need any assistance, please send me a message on WhatsApp. Okay, you need the file containing the most repeated questions by Jamb in UTME. Send me a DM. You need me to coach you for this exam that is very close now. Send me a DM. A lot of candidates are taking action. All right, let's go. The question we have here is Jamb must repeat question 1. The question reads: what is the amount of oxygen in 2.5 moles of potassium triazonitrate 5? They gave us all these. And what are these? Are they atomic mass or molar mass? Drop it in the comment section. So we are going to use this, okay, to solve. We are going to use this to what? To solve. Very easy. This one is a mole concept. They are asking us what is the amount of oxygen in 2.5 moles of potassium triazonitrate 5. They are asking us the amount of oxygen inside this. All right. First of all, since we are looking for the amount of oxygen, that's in other words, we are looking for the number of oxygen. We want to know the amount of oxygen. Let's write out the formula. First of all, the mass is equal to mole times molar mass. The symbol for molar mass is capital letter M. All right, while mass is small letter m. So you can write this formula as M is equal to mole times molar mass, which is capital letter M. All right, then if you are solving any question on stoichiometry or molar masses, or you are finding molecular formula or empirical formula, the first thing to do is to balance the equation first of all. Write out the formula, then you balance the equation. If there's any equation here, it is only formula we have. Okay, so write out the formula. Okay, make we know wetin we dey solve. Okay, writing out the formula of potassium triazonitrate 5 is what? Potassium triazonitrate 5, NO3. This is the formula. All right. So this tri means we have 3 oxygen atoms. Okay. So the number of atoms equal to 3. Okay. So equal to 3 oxygen atoms. So we have 3 oxygen atoms in potassium triazonitrate 5. So let's write out all that was given to us. Okay. All that were given to us. They gave us mole. Okay. Given. This thing not the day to solve. Now because I the teacher, mole is equal to 2.5. Okay, see I'm here, mole of potassium triazonitrate 5. They also give us molar mass. Yes, they give us molar mass. Molar mass of oxygen, capital letter M, molar mass of oxygen equal to, what's the molar mass of oxygen? 16. Okay, what else did they give us? They gave us mass. No, mass. We already have the molar mass of oxygen, which is this. So what we have to do is to find the mass of oxygen, because we are going to apply mass here. Okay, because we want to calculate the mole. So molar mass of oxygen is equal to 16. Okay, so the mole of oxygen times the mole of potassium triazonitrate 5. That's what we are going to do. So mole of oxygen times mole of KNO3. Okay, that's what we are going to do now. So the mole of oxygen is 3. We have 3 atoms of oxygen. Look at it. So 3 times what? The mole of potassium triazonitrate 5. Where is the mole? 2.5 moles. Look at it here. 2.5 moles. Okay, 2.5. And what is this going to give us? Equal to 7. Is it 7.5? 3 times 2.5 is 7.5 moles. Okay, moles of oxygen atoms. Okay, therefore the mass of oxygen will now be mole times molar mass. This one is the formula. Okay, the mass of oxygen is equal to mole times molar mass. What's the molar mass? 16. What's the mole? 7.5. So we are now going to have mass is equal to, what's the mole? The mole is 7.5. The molar mass is what? The molar mass is 16. 7.5 times 16 will give us 120 grams. So this is the what? The mass of oxygen. Okay, mass of oxygen. So mass of oxygen equal to 120 gram. So this is the mass of oxygen. Among the options, pick the correct option and drop it in the comment section. Now, I have a question. That question that we just solved now, what if Jamb asks you that, what if they ask you to calculate the total mass of 2.5 mole of potassium triazonitrate 5? How are you going to calculate it? Okay, let me just say, what if the question is calculate the total mass of 2.5 moles of what? Of potassium triazonitrate 5. How would you calculate it? Can you calculate this? Can you? Okay, let me quickly show you how to calculate it. Okay, it's the same thing, very simple. Okay, the first thing to do here is to calculate the molar mass of this. Since we are calculating the total mass of 2.5 mole of this, the total mass is now going to be the mass equal to mole times molar mass. Okay, mole times what? Molar mass. This formula that we will use. Okay, so first of all, we will calculate the molar mass of this. How do we calculate the molar mass of this? It's very easy. Okay, find the molar mass of each of them. They gave it in the question. Let me show you. This one that has 3 here, it means you are going to use 3 to times the molar mass of oxygen. Let me show you. All these are the molar mass given. Potassium, molar mass 39. Nitrogen, molar mass 14. Oxygen, molar mass 16. Now all these things you will take find the molar mass. So let me show you how to find the molar mass. Molar mass of KNO3 is equal to what? This one is 39. Potassium is 39 plus what next? Nitrogen. Nitrogen is 14, right? 14 plus oxygen. Since oxygen has 3 here, we are going to put brackets. It's going to be, what's the molar mass of oxygen? 16. Bracket close times what? 3. Okay, 16 times 3 will give us 48. So we bring our 48 down, equal to plus 39 plus 14 plus, let's just put everything together, 14 plus 39. So this is going to give us, if you plus this, is going to give us 101. What's the unit of molar mass? Gram per mole. Okay, so this is the what? The molar mass of potassium triazonitrate 5. Since we've gotten the molar mass, what do we have to do? We calculate the mass of 2.5 moles of potassium triazonitrate 5. Total mass is equal to, what's the formula? Mole times molar mass. This is the what? Molar mass. What's the mole? 2.5. All right, so we are now going to have 2.5 times what? Times 101 mole, which is the molar mass, total molar mass. This will give us what? 2.5 gram. So this is the what? The total mass of 2.5 mole of potassium triazonitrate 5. Let's move over to the next topic.